Okay, so we want to solve the inequality algebraically and show a sign graph for your work, giving the answer in interval notation. Okay, so this has multiple steps. You have a summary sheet that explains the steps that we're going to do. The first step is first to identify that it's not linear. So it's because it has a squared, this is not linear. So then I have to get 0 on one side of the equation. Oops, it's a 2. I want to keep the x squared portion positive, so I'm going to bring everything over to the left side. Now I factor. This trinomial factors as x minus 3 times x plus 1. After you've got it compared to 0 and factored, you need to find what's called split points. Split points come from setting the factors equal to 0. It does not matter if this is a greater than or equal to, greater than, less than, or less than or equal to. Split points always come from setting them equal to 0. Do not use the inequality. Use equal. And this gives us two values of 3 and -1. Now, they're called split points because we use them to split apart the number line. So you put your split points on your number line, of course in numerical order. Now we need to find what's called test points. Test points are any point within the regions that are divided up by your split points. So here I've got one region here, numbers less than -1, a region in between -1 and 3, and a region larger than 3. Pick anything less than -1. Do not pick the split point itself, something in this interval. I'm going to pick -4. You could pick -5, -200, -375.6. As long as it's in this region, it doesn't matter. And I usually put that in parentheses, my test point. Okay, now in the middle here, between -1 and 3, I want to pick 0. Any number would work, but if you can pick 0 as a test point, pick 0. Like I said, I put these in parentheses. Do not put a hash mark here because that's going to make you think it's more of a split point. Only use the hash marks for split points on your number line. And now any number larger than 3, I'm going to pick 10. Okay, now what do you do with the test points? You plug the test points into your factored portion of the inequality where you've compared to 0. And what I'm building is what's called a sign chart or a sign graph. So all I care about is the sign, meaning positive or negative. Okay, so with each of these I'm only going to worry about whether it's positive or negative. -4 minus 3 gives me a negative number. I don't care that it's -7, I just care that it's negative. -4 plus 1 also gives me a negative number. And a negative multiplied by another negative overall gives me a positive. Okay, if I'd picked any other number in this region, -5,000. -5,000 minus 3 is negative. -5,000 plus 1 is negative. And negative times negative is still positive. Any number in this region will give you a negative times a negative to end up with an overall positive when you multiply. How about in between here? I picked 0. 0 minus 3 is negative. 0 plus 1 is positive. Negative times positive is negative. And again, any number between -1 and 3 will give you a negative times positive for an overall negative. Alright, now last one. I picked 10. 10 minus 3 is positive. 10 plus 1 is positive. Positive times positive is positive. Now, probably 95% or more of the times, these signs are going to alternate, but sometimes they do not, and I have an example rigged where it does not, so you've got to test them. Okay, now, how do you use this to answer your problem? We want to know, when we plug into here, where do we get values that are greater than or equal to 0? You have to read the inequality. Because I want greater than or equal to 0, I want the positive regions. So I have two different regions here. First one starts at -infinity, and stops at the split point, -1. Not your test point, the split point. Because there's an equal to, I use a bracket. Then I have a second region, which I can use union or a comma. Starts at 3. Again, it uses a bracket because of the equal to, and it continues on out to infinity. And this is the answer to this problem.